Just to introduce myself, my name is Jamie Gillespie. I'm a senior security specialist at APAN59. Submitted to run this as a tutorial for 2 sessions, so we may have some different people coming in the afternoon session. Each of these sessions will be separate, but on the same topic of security as it goes through. I've been working through security as a dedicated profession for about 24 years with IT experience for a major internet provider before then back in Canada. Yeah, my role at APNIC Security Specialist is mostly on the outside focusing, looking at training, capacity development, government engagement and that work. When COVID hit, I was doing some internal security work because I couldn't travel, but I'm back traveling again, so I'm back with that external focus for things. This session is run a little bit differently. As you probably saw from the title, it's basically what do you want to learn, choose your own adventure sort of thing. So to that end, what I've done is I've created a voting poll system where people in the room that are here fast enough after coffee, you get to actually choose the presentations that I'm going to go through and do. I'll probably use this one voting for the 2 sessions that go all the way through. So the first and second highest voted sessions I'll be covering in the morning, and then the next most voted sessions I'll probably be doing those in the afternoon just after the lunch session. So the voting is using a system called Mentimeter or menti.com. You can either go to the website there and enter a number or just scan the QR code. It should be menti.com, and that will take you directly to the voting. So I'll just give you a few seconds to make sure that you have this open, but you should be getting an interface that looks something like this, where I start off with just a basic question about how many APAN meetings that you've been to, and then after that will actually be the questions for what security topics you wish to be learning. So yeah, make sure that you do enter into here. When we get to the voting, it's going to be, I think I've got 12 different options that you're able to vote on, and you vote by ranking them. So read through the list of 12, and when you see the ones that you are most interested in, move them up to the top and make sure that you at least have numbers 1, 2, 3, 4, and 5 as your most interested topics up there. So how many people do we have? We've got 12 people in there, so that's pretty good. So yeah, so as far as APAN meetings, a lot of people, this is their first meeting, so welcome everyone who this is their first APAN meeting. Hopefully this is the start that you'll be able to attend more in the future. Almost just as many people attended just 1 or 2 meetings, so that's wonderful. And of course, we've got a few people that are old hands and that have attended many APAN meetings as well, so good to have everyone back again. Yeah, so is everybody in for the voting that wishes to join? One last chance for anybody to join in. Good. Okay, so the second question, let me see if I can move that on. There it is. Okay, so second question is just asking what your job title is. This is to get an idea as to where people are coming from. Not everybody is a network engineer, not everybody is a security engineer or specialist. And as the first person says, if you're a student, please feel free to put in the student as well. Excellent. Good to have some students coming in. Oh, and some C-level executives. Look at that. Very good. For those that are just joining in at the back, we're just going through and doing a bit of a survey and things, and we're going to be voting on what topics are interesting people. So if you wish, you can join in for the voting. We haven't got to the topic voting just yet, but if you have a phone, you can scan the QR code, or you can use the website and number on the left as well. This voting will let you vote on what topics are presented. Excellent. So we're just going through looking at titles. So wow, C-level executives, that's wonderful. Government engineers, administrators, network security, network engineers, wonderful. And the topic that everybody is looking for. It is a little bit small font. Let me see if I can zoom it in a little bit here. So these are the 12 topics that you can vote on. You vote by ranking them. So once you move them around, basically try and have your most interesting topics up at the numbers 1, 2, 3, 4, and 5. I don't think it's going to matter too much below the first 5 rankings. But have a read of all of these topics. In brackets, I put a little bit of explanation on what it is. So up at the top, we have the cybersecurity basics for technical, looking at definitions and risk management and understanding in that. Security awareness, this is a presentation usually aimed at end users, but this presentation can be, of course, borrowed and used for your own end users if you wish. Looking at basic understanding of threats and countermeasures for confidentiality, integrity, and availability. DDoS attack prevention, intro to cryptography, password control. This password control is how to control passwords if you're storing them on a server, as well as how to control passwords for end users. Physical security, this one isn't lock picking, but it's everything around door security except the locks. So there's many videos on lock picking. I can do that one later for you as well. But this one is physical security around doors, going over doors, under doors, around doors, as well as server rooms and rack security. DNS from the client perspective is looking at DNS and DNS security, not from a DNS server, but from the clients and how they're connecting and that. And of course, at the bottom, if none of these topics interest you and you just want to do a rapid-fire Q&A and throw a whole bunch of random questions at me to confuse me, ask me anything. I think that was all of the 12. Oh, and the vulnerability reporting programs. The one about how to create a vulnerability reporting program is from my personal experience setting one up at APAN59 with a budget of basically $0. And the other one I think was, yes, vulnerability assessments, how to do vulnerability assessments and penetration testing. It is an introduction to VAPT. But if you have never done penetration testing before, it is an interesting introduction for that. And oh, yep, the one up at the top, email security. So that's going through all aspects of email security. We're looking at, of course, SPF, DMARC, and DKIM, but we're also doing a quick overview of phishing and SMTP level email security for encryption layers and stuff as well. So, do your ranking. As you see, we've got a few winners up at the top, but I'll give a little bit more time for anybody that wishes to try and change the balance. I think we've got 14 people who have put their voting in. Now, I will warn you, for those 2 that are up at the top, they are very big topics. So it's going to be one of them for this entire session, and then the next one for the entire next session. So it's not going to be like 2 different topics in this session. Not for those ones. Those are big ones. Okay. Any last chance? Anybody making any other changes? So going by this scoring, vulnerability assessments and penetration testing as an intro how-to is going to be the first topic. And then after lunch, we'll go through and look at email security. So thank you very much for that voting. And it's always the fun part because I've got like 12 different PowerPoints that are ready to go for all of this. And just one last one. I only put up 12 topics there. I'm interested if there's any other topics that you might be interested in me talking about. It may not be for today, but just an idea of where people are thinking for future security tutorials and workshops. So this can be other topics or repeat of topics, whatever you would like. And try not to say AI too many times. It's everybody wants AI security. Excellent, good, good. Oh, I don't know if I could do malware creation. Ask AI. Navigating dark web. Yeah, that's an interesting one as well. I actually have a larger presentation that I do for law enforcement agencies, teaching them about internet fundamentals. And part of that is teaching them about the dark web because they hear about the dark web, but they've never seen it. So yeah, it's, I already have a very, very small intro to the dark web. Unfortunately, any of the really good security tools for the dark web are paid tools. Some of them are amazing, but I try not to promote paid tools too often. Excellent, cool. Well, thank you very much. If anybody else does have ideas, please keep putting them in because I will get that information even if it's not showing on the screen. I do collect that information back. So thank you for that. Let me just bring up my presentation for vulnerability assessment and penetration testing. There we go. Okay, so here we go. Now, this presentation on vulnerability assessment and penetration testing is part of a hands-on interactive tutorial that actually goes through probably half a day. Now, for this quarter of a day, we're not going to have the time to do the hands-on parts, but something to understand is that at APNIC, we actually have free academy training and free labs as well. So everything that I present here, these slides will be shared out. I will have these slides put up onto the APAN program so that you can actually get these slides. You don't have to take pictures if you don't want to. You can take all of these slides, go to academy.apnic.net. If you don't have an account, create a free account, quick and easy, and go into the labs area. In the labs, you'll be, let me bring up my laser pointer. In the labs, you'll see this vulnerability scanning and penetration testing lab. It's a simple lab. It's got a few vulnerable machines and a Kali Linux workstation to work from, but it gives you a free virtualized lab environment to practice all of the steps that I'm going to be talking through and mentioning in this presentation. Also, there may be some slides that I won't have the time to go through. The slides are pretty self-explanatory, so you should be able to read through the extra slides, go into the lab, and actually do the hands-on activities as well. Additionally, the APNIC Academy is not just for APNIC members. You'll know that when you create an account, all it asks is for your name and email address. There's no other verification checks. So if you have friends, colleagues, students, other staff members that wish to go through and use the Academy, please point them. It is a free resource to use. So going through and talking about what is vulnerability assessments, what is penetration testing, and how are the two related and how are they different. So a vulnerability assessment is a methodical view looking at all vulnerabilities within a scoped environment. And I'll talk about scoping a little bit later on. The goal or the output from a vulnerability assessment is a prioritized list of vulnerabilities. So this should be listing every vulnerability that is possibly on any systems, networks, firewall rules, whatever it might be, and looking at the priority for them and ranking it that way. This allows for the risk management process to go through and actually work through the highest rated vulnerabilities that would actually have an actual impact to the organization. So some vulnerabilities might have theoretical impacts that are quite bad, but in a particular environment, they may be mitigated through other actions. So we want to look for vulnerability impact that is a real impact to the organization. Vulnerability assessments are usually performed when you know you have problems, but you don't know exactly where the problems are. If you're not already doing vulnerability assessments, not only is it a good time to start, but usually keep going. And I mentioned this on a later slide, but I'll reiterate it up front early. You can actually do continuous vulnerability assessments so that as soon as a new vulnerability is discovered in software, like Microsoft releases new vulnerabilities, you will get that in and apply it to your environment. Additionally, if new software is installed on your environment that has a vulnerability, it would be detected quickly. Vulnerability assessments are only as good as the frequency that you perform them. If you do a vulnerability assessment once a year, that leaves you 364 days where things can be changing, things can be getting worse, and you don't know what's happening on your network. The vulnerability assessments can be performed either network-based, usually without credentials, or host-based, where they can actually be connecting into the computers and interrogating the systems themselves for the software that's installed and the configuration is and what vulnerabilities are there. These host-based scans are usually done with an agent that is installed on the computers, but it can be done just with a username and password, a remote connection into the machine, and interrogating it that way as well. Vulnerability assessments are very commonly done as part of an audit. Depending upon your statutory or compliance requirements, you may have to do a vulnerability assessment every 6 months or every 12 months or more frequently as well. Now, looking at penetration tests and how these differ. So a penetration test is a simulated attack within, again, a scoped or defined network. Now, I say simulated attack, it's sometimes seen as a real attack, but by a good person. So it's not just scanning the network looking for things, but it's actually finding a vulnerability and seeing if they can break in through that vulnerability, actually testing to see if that vulnerability is real or just a potential one. The goal of penetration testing is to not just break into one system, but to get to a valuable point within a network. This is sometimes defined as the crown jewels or some sort of high value system. For some organizations, this might be a human resource or a student database. Other organizations, this may be a finance database. When learning penetration testing, it's usually done with competitions called Capture the Flag. And Capture the Flag, if you've ever played either the virtual ones or the physical games of Capture the Flag, you're trying to find a flag, something that you can prove that you have gone into the enemy territory and grabbed something that is valuable. In computer terms, the flags is usually evidence that they have access to file or a database or a system, and that they can prove that they have access to that information. Penetration testing is usually done for more mature defenses. If you have never assessed the security of your network, you would not want to dive straight into a penetration test to come in and do that assessment. And that's because penetration testing is all about getting to the goal. You know, if my goal is to get to that projector, I only have to go through a few chairs and cables to get there. I don't have to go around the entire room, checking the entire room on where I'm going. So a vulnerability assessment is going through methodically checking everything on a network. Penetration testing is eyes on the goal and trying to get there through any means possible. And of course, penetration testing is like hacking. This is what you see done in the movies when people are testing their own systems. Vulnerability assessment is not exciting and doesn't really make it into the movies at all. Now, for both of those types of assessments and testing, we talk about scope and scoping of a system. Defining the scope is one of the most important things, and this basically sets the boundaries. This sets the boundaries on how wide that we are looking across the network and systems, but for some scoping, it's also how deep that we are going. What types of testing, how intrusive is the testing going to be, and what type of damage might we cause along the way? One example of this is denial of service within the scope of something that can be done. Now, for a lot of testing, it's going to be no, we don't want to go through denial of service, but it might be a matter of, well, do we want to look for vulnerabilities, but maybe not test whether they are vulnerable to denial of service? And this is because there are a lot of ways to do denial of service. Of course, just straight up volumetric data, getting a large botnet to overwhelm a network, is a type of denial of service attack. And almost everybody is going to be vulnerable to that at a certain point of traffic. The other part of scoping a system, scoping an engagement, especially for penetration testing, is setting what the goal is going to be. What is that high value target that you want the penetration testers to try and reach? Or maybe there's a few different high value targets allowing them to go different routes from there. Something else with scoping of networks and that, especially when it comes to penetration testing, is the physical world in scope or out of scope? And by physical world, I mean actually going to a university site, going to an office building, and dropping USB keys around to see if someone's going to pick it up and plug it into their computer. Or are you allowed to call up people within an organization and pretend to be the IT help desk and try and get access to their computers using social engineering over the phone? If these things are allowed, you're getting a very comprehensive test, but it's not necessarily testing the network and computer defenses. You're testing the human defenses at that point. When doing the testing, usually for penetration testing, there's two very large groups of testing. That's a black box and a white box test. This goes back to electronics testing and physical testing that's been done before, where a black box testing was literally a black box. You would have some connections coming in, connections going out, but you can't see inside for what the electronics are. In testing for penetration testing, a black box test is where you don't give any extra information or you don't give extra access to the people doing the testing. They're basically given your IP addresses, maybe your domain names, and that's it. They don't have network maps, they don't have credentials, they don't have access to a physical port inside of your network. White box testing, on the other hand, is where more access is given. Here's a network map. Here's a port inside the network where a regular workstation would be. You can plug in here and do testing from that location as well. Now, these have pros and cons on both sides. Black box testing is a bit more realistic for somebody that is a malicious attacker trying to come in and trying to break into your network because they may not have that privileged access or information. And white box testing is going to be speeding things up a little bit. If you can say, well, over time, an attacker would be able to get all of our IP addresses, would be able to get our domain names, and would be able to map out our network, you're just speeding things up a little bit. So by doing a white box, you're moving faster to the point where they're doing actual attacking on your vulnerabilities to do that assessment. So if you have a lot of money, you can start with black box. Now, when we're basically paying people to assess our vulnerabilities and break into our networks and systems, we have to understand the legal issues around this. And especially if you yourself are going to be doing any vulnerability assessments or penetration testing on your networks, you are the one that is directly impacted from those legal issues. So you need to understand this as well. When performing the actions of an attacker, it's very important to stay on the right side of the law. Almost every country in the world has some sort of telecommunications or cybersecurity law that says unauthorized access is against the law. And depending upon where you are doing it from, doing illegal access from a network against a network, if they're in two different countries, may be breaking two different laws as well. So depending upon how things are going, you could be in trouble with different countries. As you go through, if you become a penetration tester, all these training courses, exams, and certification programs, they have entire modules and chapters dedicated to all of the different legal issues. I can't go through all of them here, but it is understood that you have to have permission and you have to understand what to do when something unexpected comes up. If you discover a brand new vulnerability, who is the owner of that vulnerable information? Who do you have to report it to? And that needs to be written down, that needs to be understood in a contract. For you, if you are doing penetration testing activities, or if you're hiring someone in, everything needs to be very clear. Foresee these little edge cases that may come up. When it comes to the legality of the testing, of course, we have the black hats and the white hats. Very simply, black hats are people that are doing things without permission. They are the ones illegally doing it, typically called criminals. White hats, these are the security professionals. These are the ones that are doing it with permission, usually working in the field, possibly doing defense, sometimes doing the testing internally. But then there's these gray hats, and some people talk about gray hats in different ways. The annoying thing is that there is no clear definition of what a gray hat hacker actually is. So whenever you speak to somebody and they say, oh, you know, this person's a gray hat, or, oh, I've been thinking about doing gray hat hacking, the very first thing is, what do you mean by that? What is your definition of gray hat, so that there's a common understanding? Gray hat could be a black hat hacker who has gone and done illegal things in the past, and they are trying to go professional. They're trying to go good now. They're stopping their illegal activities. But of course, they have an illegal background now doing professional security work. So that's one direction that it is. Another is that you may have somebody who's a security professional in the daytime, maybe doing vulnerability research and learning about new vulnerabilities and discovery, and then in the evening, going home and using that information for illegal personal benefit and gain. So maybe somebody who's dancing on both sides of the legal boundary for that. So different definitions, good to understand what each person is saying. Now for penetration testing, like for vulnerability assessments, we mentioned that you're after a prioritized list of vulnerabilities, pretty straightforward. For penetration testing, there's a lot of different people that can perform penetration testing activities, and they can provide you with different levels and different types of information on those reports at the end. So a couple things that I'm going to mention that are good things that you want to be looking for in a penetration testing report is you want to be able to show the dramatic proof that a vulnerability is an issue and can be exploited on a network. Not just a matter of scanning for vulnerabilities, but proving that you can break in through that vulnerability and do some harm on the other side of it. A good report is also going to be documenting all of the actions that the penetration tester was taking, so that if you have hired a penetration tester, you can see the steps that they were taking, see the tools that they were using, and you can reproduce that yourselves. And this is useful that if you're going through and fixing the vulnerabilities, as you should, that you want to then retest afterwards. And if you have a list of steps that have been taken, you can fix the vulnerability and try and reproduce it yourself to make sure that whatever vulnerability fixes you put in place are sufficient to protect your systems. Also, a good report should detail the amount of effort that it took for the penetration tester to break into your network. This is the difference between downloading a free tool off of GitHub, running it once and breaking into a network, or spending 3 days researching a brand new vulnerability and writing some custom code in order to break in that somebody else has never done before. One thing basically opens up that any teenager anywhere in the world can do, and the other is taking very specialized skills and time in order to try and exploit that system. And probably the most important thing if you're receiving one of these reports is that you want actionable intelligence on how to mitigate these vulnerabilities. You just don't want, you have a vulnerability and this is where it is. You want some advice. What are some things that you can do to fix that vulnerability? Or if it's a vulnerability that doesn't have a fix, how can you put other layers of security in place so that you can help mitigate or reduce the serious nature of that vulnerability? Now, I said that I'd get to this point, regular security testing. Regular security testing is so important because things are changing so rapidly. Every day, new vulnerabilities are being discovered and announced and made public. You could keep the same software installed all across your network, but over time, you will have more vulnerabilities. Not because you're installing new vulnerable software, but because new vulnerabilities are being detected in the existing software. Microsoft, every month, sometimes every week, they are releasing brand new vulnerabilities and the fixes for them as well. With no new software, your list of vulnerabilities will increase over time. Because of that, you want to make sure that you're testing more frequently. You know, the optimal position is continuous vulnerability assessment. And that's basically where all the time your systems are reporting what software is installed, the configuration of that software, the versions of that software, and if you're doing active scanning across your network, as soon as you're done scanning your network, you start over at the beginning and you just keep going continuously. This allows you to reduce that window of being vulnerable and not knowing about it. That's the worst situation to be, because if you don't know that you're vulnerable, then you obviously can't do anything to protect it. So getting into the actual, intro to penetration testing side of things, when doing penetration testing, you basically are thinking like a hacker, and I use hacker in the illegal attacker sense, not in the traditional hacker of somebody who's learning and playing and exploring. So yes, I am using the negative term for hacker here. You're basically acting like a hacker. You have to be thinking like a hacker. You have to be thinking about ways to break into systems, to find the weaknesses and exploit them on the way through. But you have to make sure that you're, of course, doing that on the legal side of things. So to understand the mindset of a hacker, you have to go through and understand a life cycle of how are the common steps gone through. This also allows you to break down these steps to look at defenses. How can you defend against each one of these on your network? So the attack life cycle starts off with initial reconnaissance. This reconnaissance is not just scanning of a network, but this could be passive reconnaissance, where you're going to other websites that may already have information about the network or the systems that you're looking at, and you can passively collect that information without ever touching the network whatsoever. One example for this is Shodan. Has anybody heard of the Shodan website? Excellent. So Shodan is continuously doing port scanning and other things across the entire internet. You can go to Shodan and query their database to see the information. Meanwhile, you are never making a direct connection to the target network. So using Shodan is passive. Shodan themselves are a more active reconnaissance type of network. Same thing, accessing DNS. If you access DNS using regular recursive DNS servers, that is a more passive way because you're not directly connecting to the authoritative DNS server. So the initial reconnaissance, collecting information, collecting email addresses or the format of email addresses, locations, IP addresses, domain names, usernames, port numbers that might be open, everything like that. From all of that information, you can find the weaknesses that you want to exploit, and that's going to be this initial compromise. The initial compromise here is actually breaking into the network for that first time. This is going to be the first point connecting in, and then we're going to do more things later on. So if it's a very locked down network, this might be an exposed service like a web server, where they have to be listening on port 443, maybe port 80, and this is where you can make that first break-in through a vulnerability. Once that you break in, it's then going through and establishing a foothold. Many vulnerabilities are not reliable, and many vulnerabilities will get patched and fixed over time. A vulnerability that exists today may not be there tomorrow. So by establishing a foothold, you are providing a way that you can get back into that system. This might be like a reverse SSH proxy where you can make an outbound connection, allowing inbound to come back over that tunnel. This might be creating a username and password on the system so that you can log back in with valid credentials, but providing some way to get back into the system. The next step, if you haven't got administrator or root access already, this is where you want to try and escalate your privileges. All of the really exciting stuff happens with higher level privileges like administrator or root. This also allows you to hide your tracks more, and it allows you to have more complete access to a system. Now, this loop that we go through here is basically lateral movement within a network. This loop is not just a one-time loop, but it's continuous as many times as needed. From having a foothold and escalating privileges, you then do internal reconnaissance. This is looking around, once you're inside a network, what can you see that was not visible from the outside? So if this is a very locked down network and you're able to gain control of a workstation, you might now be able to scan the entire workstation network and maybe any internal servers that that workstation would have access to as well. From that internal reconnaissance, it's very similar to the reconnaissance that we're doing up front, is that you want to move laterally. You want to compromise the other machines. Maybe you've broken into a workstation and you have the administrator password. If all of the workstations have the same password, you can now hop from one workstation to another because they're all reusing the same administrator password. Moving laterally lets you then gain access to other computers, gain access to the information on those other computers, and build up more of a map of information and systems that you'd have access to. Once you move laterally, you want to maintain presence. This is like establishing a foothold, being able to get back into these other systems as well. And you basically can keep looping around here, escalating privileges if needed, doing more reconnaissance, more scanning. Once you get onto one, maybe segmented network, you can then scan the rest of it. And maybe from there it has a connection to another segmented network and do scanning from there. This circle may not exist. You may not need to go through this. You may need to compromise one machine, and that gives you everything that you need. You may want to do this cycle a few times to get to the right machines. There are some very motivated attackers that will actually infiltrate all aspects of a network, and they will actually build a better network map than what you might have or that your network engineers may have. And that's because they're motivated. They are very, very strongly motivated to understand your network so that they can go in and find the weak points as well as the most valuable servers or information that they can gain access to. And that's what this last completing the mission actually is. what is the purpose of this exercise? If we're doing it as a penetration test, this would be trying to find those crown jewels, trying to gain access to those sensitive systems to prove, yes, I was able to break into the network. You do have real vulnerabilities. From a criminal's perspective, completing the mission here is usually based on financial motivation. There's many other reasons for criminal activity, but a lot of things revolve around money. Is this a matter of stealing information, maybe encrypting some hard drives, and ransoming for that information that they have stolen from there? That's a common one for the financial motivations. It might just be very quietly stealing information as a nation-state attacker that is trying to gain competitive advantage from another country, stealing intellectual property and using it for their own manufacturing and their own benefits. Now, when it comes to actually doing some of the steps and the tools and the activities that I'm going to be going through here, please remember that this is expecting that you're going to be using the APAN59 virtual lab environment. It does not have outbound access to the internet. So the virtual environment is well protected. It is also using private 1918 addresses, so 192.168.30.x. Make sure that you are staying within these networks. If you are running these tools on your own computer, it is your own responsibility to make sure that you have permission for the networks that you're using it on. Just because you are a network engineer or a security engineer at an organization does not automatically give you permission to use these tools and to do scanning and to do penetration testing on your networks. Make sure that you get very explicit written permission to do any of these tools or activities on live networks that you do not own. So especially within a workplace, that applies there as well. If you wish to create your own virtual network on your own computer at home using VMs and networking that you control, of course, it's definitely your own network. You give yourself permission. Definitely be careful going out on public IP addresses. This is just login information for Kali Linux. It's default usernames and passwords. It's a protected network, so we don't have to worry too much. So having a look at this, what we're doing is we're going to be starting off with the reconnaissance phase. So when we look at this diagram, you can see that I've drawn a little box around initial reconnaissance. A lot of the tools that we start off with are different tools for reconnaissance. I'm not going to be going into using Shodan and stuff like that. I'm doing active scanning intelligence and reconnaissance at this point in time. The first tool that we're looking at is Nmap. Nmap is like the OG as far as network security and scanning tools. Nmap stands for Network Mapper. It's been around about as long as I have in IT, so I can't remember exactly when it was created, but probably about 25, wait, what year are we in now? 27, 28 years ago, Nmap started off as a simple port scanner. Since then, it's increased with a lot of other tools. It's been increased and extended with plugins that you can either write yourself or use others that have been written, and do much more than simple port scanning now as well. Just for your reference as you go through, if you were to use these slides later with the lab environment, anything that you see in green with the courier font is going to be things that you're typing in. Anything in the little angle brackets is like a variable where you can replace that with the actual IP address that we're going to be using. So for example, the first line that we're seeing here, nmap-s and then a capital S, and then Meta2's IP address, or as you see on the next line, the full IP address. That is the actual thing that you would type in on a terminal within the Kali Linux workstation that we're using. So what we're doing is we're starting off with very basic understanding of Nmap. -S is standing for scan. So we are initiating a scan of an IP address or of a network. And the second S that you see here, the capital S, that is the type of scan that we are initiating. And this is a SYN scan. So lower s for scan, capital S for SYN. Now, if you remember your three-way handshake, as everybody should understand the TCP three-way handshake, the computer makes a SYN connection. It sends a SYN packet, or a packet with a SYN flag, sends it to the other end. They respond with a SYN ACK, and then you finish off with an ACK in the direction. This is actually broken down into two completely separate steps. It should be like a four-way connection back and forth, but the middle two are condensed. So when you send a SYN in one direction, you're getting an ACK back. And then for the other direction, the other side is sending you a SYN, and you are doing an ACK back. But those middle two, ACK and SYN, are combined into a SYN-ACK. So in reality, it should be called an ACK-SYN rather than a SYN-ACK in the direction that we're using it here. Either way, three-way handshake, you send a SYN, you get back a SYN-ACK, and then you finish with an ACK. That is proving that the port is open and you're connecting. But to prove a port is open, you don't have to finish the connection. If I send a SYN and I get back a SYN-ACK, that proves the port is open. I don't need to finish with that final acknowledgement. And that's what this scan is doing. It sends a SYN, it listens for a SYN-ACK, and it stops. If it doesn't receive a SYN-ACK, the port is considered closed. If it does receive a SYN-ACK, the port is considered open, and it stops. This is a very fast scan because these packets have no data. It's only the flags in the TCP headers that are being sent back and forth, no actual data. Additionally, it's not building that TCP connection on the other end. It's only just checking the half-open connection if it's open. The other nice thing is that from a server's perspective, they do not see the connection finishing. So the only thing really that would detect this would be a network firewall along the way or some sort of very intelligent endpoint system that is looking for these sorts of half-open connections. So very fast, can evade some server detection or server logging. One of the downsides, though, is because we're not building a full three-way handshake connection, we can't send data back and forth. So we can't talk to the port and send a hello message or to listen for a banner or anything. The only information we get from this is the port open or closed or filtered. The next one that we're going to move up in the scale of things is we're going to do a bit more of an active scan. We're going to actually open the three-way handshake and we're going to listen and talk to the other side. So here, what I'm introducing, instead of a SYN scan, I'm doing a version scan. So lowercase s for scan, capital V for version scan. I'm also introducing a new option here, a -O. This is doing an OS detection scan as well. So one step at a time, the version scan finishes the three-way handshake, talks to the other side, and listens for a banner message. Most server applications will actually advertise themselves when you first connect to them. They will say, if you connect to SSH port, it will respond and say, hi, I'm running OpenSSH version 123 on this protocol and this level of OpenSSH protocol. Or if you connect to an SMTP server, it'll respond and say, hi, I'm an SMTP server running this software and this version of things. Almost every server that you connect to is by default going to give back this information to you. And this is the information that we're interested in. We want to know what software the server is running and what version it's running as well. This allows us to then look up in other databases, even just doing a Google search. Are there any vulnerabilities in OpenSSH version 1.2.3, for example? A simple Google search like that will tell you any of these websites that track vulnerabilities on specific versions. The next part, this -O, This is not 100%, but this can give you some useful information. Now, you may think that TCP/IP is implemented the same everywhere because that's how interoperability works between systems. Every computer on the internet has to talk TCP/IP so that they can communicate to each other. But here's the thing, the RFC standards or requests for comments for TCP, IP, UDP, they all have a little bit of wiggle room. They all have some slight differences that can be implemented in TCP stacks in the kernel on different operating systems. And every kernel and operating system does things just a little bit differently. By sending special packets and looking at the flags, looking at the window sizes, looking at acknowledgement numbers and how they increase and change, you can get a rough idea of what operating system is on the other end of that connection. And that's what this OS detection is actually doing. It's doing a little bit of fingerprinting of an operating system's kernel using those TCP stack differences that every version of operating system does. So pretty neat stuff. So not just telling you whether it's Windows or Linux, but telling you which versions of the Linux kernel it might be. Now, it is kernel-based, so of course, if it's running Linux, but it's running, all of these distribution things, or it's an IoT that's running embedded Linux, you may not get those specifics, but you will at least find out the kernel understanding of what's underneath it. The next scanning that we're looking at here, I'm introducing the capital U. That's looking for a UDP port scan. So lowercase s for scan, capital U for UDP. UDP scanning, of course, is not setting up a three-way handshake. It's basically sending a UDP packet and waiting to see if there is a reply. Because UDP is connectionless, we have to wait for several seconds to see if we're getting a reply or not. If we don't get a reply after a timeout, it's considered closed. If we do get a reply, great, we have an open UDP port. Not as many interesting things happen on UDP when it comes to vulnerabilities. TCP is most of the space where it is. So we don't go too deep into the UDP side, but also because UDP scans are very slow, for learning purposes, I'm introducing the -P option here. And this is setting a port range. Now you can use -P up here. You can define what TCP ports you wish to scan as well, but down here we're using it for UDP. So we're only setting from ports 50 to 170 that we want to scan for the UDP, just so that during the learning exercise you get a little bit of a faster response. If you scan 1,000 UDP ports, it's going to take much longer to do for every single system on the network that you're scanning. The next bit for the introduction here is looking at output options for Nmap. So Nmap, by default, will give the output on your terminal screen in front of you in the terminal window or command prompt window that you're running. But if you want to output to different files, you have different output options and output formats. So here we're using the scan for version numbers again, but we're introducing -O, that's a lowercase o for output options, and a capital X. And that says that the output format is going to be an XML format. So here we're putting in the file name that we want the output to go to, and then the IP address that we want to do the scan for. Now, the XML files on their own are not very interesting to us as humans. You could do, as I say here, you could do a less on this file, look at the contents, and you just go, wow, there's a lot of random text in here. It's not meant for human readability. The XML format is for computer readability. It's plain text, it's not a binary file, so you can look at it, but it may not be too interesting for you. Now, the reason why we're looking at this XML format is because I'm actually looking at a new tool, well, not new, but new to the slides here, new to the training, that is bundled with Nmap. So Nmap as a package doesn't just have the Nmap executable, it also has the ndiff executable as well. Ndiff is like the regular Linux, Unix diff command for finding differences in a file, but it's specifically modified to understand the Nmap XML format. And because of that, you can take two different XML outputs from Nmap and do a difference to see what is different or what has changed. Now, there are some limitations for this. The Nmap scan has to have all the same options. So when we look back here, if we ran -sv, then if you're running and comparing two scans, they both have to have -sv. You can't compare a TCP scan with a UDP scan. Of course they're different. They're completely different. So you have to compare apples with apples. You also cannot compare different IP addresses. So if you're scanning this network and then separately scanning this network, you can't compare the two because they're totally different machines. So what this does allow you to do is scan the same network or the same hosts with the same options at different times. And this allows you to then do a difference and look for changes over time. Now, the best example that I've got for this is setting up an Nmap scan that you can do in the middle of the night across your server network or your out-of-band network management network. And you can scan that network in the middle of the night, save it to a file. And then what you can do is after that scan finishes, compare today's scan against yesterday's scan. That difference will show you any port changes, any version number changes, anything that Nmap can respond with and actually show you the changes from one day to the next. You can write up a very short little script that runs Nmap, takes the output file, does an ndiff against yesterday's ndiff with some having a date and time in the actual file name, and take the output of that difference and send it to you by email. Now you can come into the office, 8:30, 9 o'clock in the morning, and you have an email waiting for you. What changes have happened on the network over the past 24 hours of time from an Nmap network perspective? This will also then show you if firewall policies have changed. If a policy has been implemented to block certain hosts from the scanning side of things, and that policy was to be disabled, now you can see more of the network. That's going to show us a difference. So the network differences that you're seeing here are possibly showing firewall policy changes, showing server changes, port changes, version number changes on banner messages, all of these sorts of different things. Now, you don't have to run it even just every 24 hours. Another option is to run it every hour, comparing against the previous hour. And if you're doing it on a small enough network, these network scans can be very quick. So you can actually alert yourself for something that has changed in the past hour and have that sent to your email with a higher priority, maybe have it sent to your mobile phone as well. So within an hour, while you're out at lunch, you can have a notification that something has changed on your network, and you can then go through and investigate, hey, why has this changed? Is this an approved change, or is this something that is maybe indicative of attacker activity on your network? And these are all free. And you can customize this, you can run this however you want, doing these differences. On Linux, it's as simple as this ndiff and pipe it into a mail command and email yourself the output. I won't go too deep into this one. It's just an understanding that if you're more of a graphical person and you don't like doing a lot of the hands on the command line or running scripts to do things in a more automated fashion, there are graphical interfaces to Nmap and other scanning tools that you can use. So if you want to speed things up, do things from a graphical perspective, there are tools like Sparta that you can use. Sparta is a graphical wrapper, not just for Nmap, but for other scanning tools that will try and do guessing of passwords on databases, will connect to web servers and take a screenshot of what the website looks like. A whole bunch of things like that. Another introduction here is going further with Nmap, is that Nmap has the scripting engine, NSE, Nmap Scripting Engine. The scripting engine can be activated by -- script, and the names that you can use here can use not regular expressions, can use wildcards for the naming of what scripts you wish to run. If you just run script equals default, there is a default collection of scripts, usually for reconnaissance of collecting information, but there's other ones that will actually try and go through and enumerate usernames and passwords and things like that. You can see here that I'm running script equals smb-enum star. So the naming of these scripts is the beginning is the most general, and then it gets a bit more specific. So SMB is a protocol, server message block for Windows file and print servers and things. So we can actually do SMB star, and that would do every script starting with the name SMB. Similarly, if you were doing against an FTP server, you could have script equals FTP star, and it would run every script for FTP. Now, obviously, the SMB is only going to be useful for SMB ports, which is why I'm defining P as 445, and that's the NetBIOS over TCP port here. So if you're doing this for other services, SMTP, FTP, or similar, you might want to change the port number and get the extra information from there. So yeah, so that's the scripts that you can run for extra information. Won't worry about that one too much. An interesting one for network engineers and people running networking equipment as well is SNMP, the Simple Network Management Protocol. Here, what we're doing is we're looking at a couple of different things. First off, introducing the concept of word lists. Word lists are, as the name suggests, a list of words. For SNMP, what we're looking at is a list of words that are common SNMP community strings. Public, private, God, Cisco, password, passphrase, all of these things that are default community strings. Every vendor, every software version has different SNMP community strings. It puts in all the default ones in there as well. And what we're going to be using is we're actually using a tool that scans for SNMP ports that are open, and it tries every one of those passwords, well, not password, but community string. And it tries all the community strings, seeing if it can connect to the SNMP server and get information back with the correct community string. So from here, it's basically doing a brute force for SNMP community strings. And because this word list here is just a text file, you can add in your own community strings. So for example, if you're changing your SNMP community strings and you want to see if any devices still have the old community string, you can edit this text file, add in your old community string, and do a brute force scan across your entire network, looking for any open SNMP ports, 161 UDP, trying the community strings and seeing if that old community string is working on any device anywhere on your network. So this is a way that you can audit for changes that you're doing on your network, as well as maybe any network devices that have default SNMP community strings and not something that is more personalized for your network environment. We then have tools where you can interrogate SNMP fully. SNMP walk has been around almost as long as SNMP, and this allows you to connect to an SNMP server, give it the correct community string, so we're not brute force guessing here. If we brute forced previously, you take the correct community and use it at this point. And it actually allows you to walk through the entire SNMP tree to pull out every single value that SNMP is going to offer over port 161. Now, in this environment, when you go through this testing here, you're basically just talking to a Linux server via SNMP. It doesn't have a lot of exciting things. But if you were to have a router or a switch that is running SNMP and you communicate to that, you're going to get a lot more interesting information. Every interface and sub-interface is going to have information about it. And depending upon the vendor of equipment that you're using, you may get configuration information as well. Some of it might even be a little bit sensitive. So if you want to see what information you are exposing via SNMP, this command here for SNMP walk will show you every possible bit of information that SNMP is offering up. Now, usually, we're just using, as network engineers, we're just using SNMP for the numbers. How many packets have gone through this interface? How many bits or bytes have gone through this interface? You get that, you save it, and you show a graph over time. And this is your, Nagios and, MRTG is the old ones, but the network monitoring and graphing for bandwidth and traffic and packets per second. There's a lot more information via SNMP, and we do have to be concerned about that. Also understanding that there is SNMP version 3, and it actually uses a proper username, password, and encryption to protect the SNMP connections. So if you're seeing all of this and you're a little bit concerned, it might be time to look at increasing up to SNMP version 3. Getting on to the vulnerability scanning a little bit. We've got a tool installed on this system called OpenVAS. Technically, OpenVAS has gone through some name changes called Greenbone. Greenbone is a commercial entity that's picked up the open source project and is sort of maintaining it and extending it a little bit. But at the core, it's still called OpenVAS. So OpenVAS, maybe Greenbone that you may see. This is a free, or at least the open source version, is a free vulnerability scanner. This is really great because for a lot of organizations, if you don't have the money for one of these high-end commercial vulnerability scanners, you do have a free option. You also can go to the commercial vulnerability scanners and get like a 1-month trial or something like that, but at the end of the 1 month, you're sort of done. OpenVAS actually started off as Nessus. You may know Nessus currently is owned by Tenable. Nessus, back in the version 2 stage, was open source. We're going back 26 years as well now, I think. 26, 27 years ago. Nessus 2 was forked off, and that's where it was then closed sourced, developed as the commercial product under Tenable, and that started them off as a company. OpenVAS was continuing the open source version of Nessus 2 and built into the product that it is today. Yeah, really cool stuff. The version that we're running is a little bit older, but the interface is all the same. You can actually go to Greenbone's website and download the community version, which is the open source one. They even have some containers for it if you're running containerized systems. You can also download an ISO if you want to run it up as a whole virtual machine as a pre-built system if you wish. The community one is free to use perpetually, so you don't have to worry about that. Here, this is just starting it up. I do have a walkthrough that I can go through, but basically the interface is pretty simple to use. The creation of a new scan is as simple as going to Wizard, typing in the IP address, and hitting scan now. It doesn't get any simpler than that. When you get the output, it gives you all of those things that I talked about before. It gives you a prioritized list of every vulnerability that it can detect. And it's prioritized using the CVSS score. So if you get a 10.0, that of course is the maximum number on the CVSS scoring for the most sensitive, the most severe vulnerabilities that can be found. With OpenVAS, it does similar things to the Nmap scanning. If you scan one network using the same options multiple times, it allows you to look at differences over time. And you can then graph that out, and it graphs it out for you automatically. So if you run an OpenVAS vulnerability scan and set it to run at midnight every day, you will be able to graph the changes over time. And especially if it's updating its database with new vulnerabilities, even if you don't change anything on your network, you'll see those vulnerabilities go up as Microsoft and all the other vendors are releasing new vulnerability information and hopefully patches. OpenVAS is really great. It doesn't just tell you the vulnerability, it gives you the scoring. It also gives you information about how to fix the vulnerability. Is it maybe a patch or an update from the vendor? Do you have to change configuration options? Or is there currently no fix available? It will give you that information. You can also create different user accounts to access OpenVAS. So you as network engineers or CISOs or whatever may have full access to it, but you can create read-only access and give that access to different people, like maybe network engineers or database administrators. They can go in, they can look at their own systems, they can see the vulnerabilities, they can read how to fix it, and they can basically monitor their own systems from a single vulnerability scanning point of view. So really great tools. There are, of course, commercial versions out there. Greenbone runs a commercially supported version of OpenVAS. Rapid7, Tenable, Qualys, these all run commercial versions as well. They all offer you trial versions. So if you ever wanted to do things, you know, on the cheap, if you don't have a lot of money, go through, run OpenVAS, get the free version, run it, find all your vulnerabilities, fix as many of them as you possibly can, and get to the point where you're happy that you've gotten rid of all the high severity vulnerabilities. Now, maybe go to Tenable, Qualys, Rapid7, get a trial version of their software, see if it finds anything different, and then fix those vulnerabilities well, and look at what software finds different vulnerabilities and get the most out of it that way. So you don't have to pay for big, expensive vulnerability scanning. Obviously, the expensive stuff is very polished, usually. Gives you very pretty interfaces, pretty reports and things like that that you might not get with the free versions. But the expensive ones can be very expensive. So if you can't afford commercial versions, please know there are open source community versions as well. Now, those are mostly the network vulnerability scanning and looking for vulnerabilities based on applications, server versions, things like that. We actually have other tools. Nikto is an example of one that is specific to a certain application. Nikto is a web application vulnerability scanner. So Nikto only works on web servers. It doesn't scan for other ports. You have to point it at the right port on the right server. And it will go in and interrogate not just the web server, but if you're running a content management system as well, like WordPress, it'll go through and look for WordPress vulnerabilities as well. So really interesting stuff. The downside of Nikto, oh, it's free as well, by the way. The downside of Nikto, though, is there can be some false positives. Just the way that some web servers respond with 404 errors that look like real web pages, it sometimes can get a little bit confused. So as much as OpenVAS is relatively clear-cut, you see a vulnerability, there is a vulnerability. With Nikto, you have to understand web server security and web application security a little bit more, and you have to go through every line that it gives you and do a bit of validation. Is this a real vulnerability or a false positive? You also then have to assign your own scoring. How serious of a vulnerability is some of this information that it's giving back? So it's a great tool, but it does require a little bit more thought in, is this real or not? And do I have to ring the alarm bell, or is this like a low-level vulnerability that could not be exploited by an attacker? So a lot of those tools, or all of those tools that I went through, is that initial reconnaissance point of view. The next bit here, in the 10 minutes that I have remaining for this session, is going through the next boxes. And this is where things get really interesting. This is where we actually do our initial compromise. We actually break into a system, and we actually establish a foothold, gain some elevated privileges, and start moving around on the network. Now, in the APAN59 Academy Virtual Lab, we have the one Kali Linux workstation that we're operating from, and we have 2 servers. These servers actually have a lot of vulnerabilities in them by default, on purpose, a lot of vulnerabilities. So we actually go through, and we've got 2 exercises here. The first one, we're attacking a Linux machine, and the second one is going through and attacking a Windows machine. Very similar in the process, but we're just finding a different application on the server with a vulnerability and doing attack slightly differently. So I'll walk you through this first one here, where we go through and we attack a Linux machine. Now we're using an open source tool here called Metasploit. Metasploit was open source software. It then was picked up by Rapid7, who are continuing the development of the open source while providing a commercial version if you want automation and fancy interfaces and stuff like that. We're using the free open source version here. Metasploit is penetration testing software. This is basically where we go from scanning for vulnerability to trying exploiting a vulnerability. Now, for the definitions for those that may not be familiar with scanning vulnerability and exploiting, scanning for vulnerability is like going up and looking around a house, looking what doors we have, maybe jiggling the doorknob a little bit, looking at the windows and tapping the windows like, is this window made of glass or plastic? Metasploit is where we take a rock and we throw it at that window and see if it breaks the window. We also have parts of Metasploit that allow us to then crawl through the window and start looking around inside the house that we just broke into. So this is where we start getting to that point of potentially doing very illegal activity if you don't have permission. This is picking up a rock and throwing it at windows. So be very careful that you are only doing this on systems that you have permission to be using it on. So we're going through and we're setting up a scenario where we take all the things that we've learned before and we're using them step by step on the way through. So the first step, we do an Nmap scan. We pretend that this is a new system that we've come across. We do a version scan, look at all the TCP ports that are open, and we look at things that might have vulnerabilities. We find an FTP server. It's the first one on the list because FTP uses a very low port number, and it's running the software called VSFTPD version 2.3.4. Now you can take the word VSFTPD 234, put it into Google, and say VSFTP 234 vulnerability. And you literally just do a simple Google search like that, and Google will give you results and say, yes, there is a huge vulnerability in this version. And you go, great, awesome. Let's run up Metasploit, because it says that Metasploit has the exploit for this version. And from here, we actually go through, and from Metasploit, it's very, very simple to use interface, search VSFTPD. The output is going to be what you see here. You see that it actually uses a bit of a directory structure. Exploit, Unix, FTP, VSFTPD. So that pseudo file structure, directory structure there, goes from the most generic to the more specific. So here we're looking at all exploits, then only for the Unix, Linux systems, then for the protocol FTP, and then for the specific software and version number. You can see here that it's got a rank of excellent, which means that it's a reliable exploit tool. and description of VSFTPD 234 backdoor command execution. Sounds great. Excellent. So once we've done a search for that, there's only one response, which is great. We then use that information. You can use tab complete to make your life easy. And then you can run the info command. And this will give you all the information about this particular exploit. What is it? What vulnerability is it attacking? What information do you need in order to connect and use it? And what type of access will you gain by running this exploit? You can also run show options because there's different options to set. If FTP is running on the default port, it's not a problem. But if it's running on a obscure port like 5000 or something, you have to change the port number that you're attacking. Here, the only thing that we need to change is the remote host. So we're setting our host. We then want to find out what payloads are there. So what do we want to do after we break in? So show payloads give you a list. You choose one from there, and we're choosing Command Unix Interact for interactive Unix shell. And then you run. You can also run the exploit command. Personally, I think exploit is a lot more interesting than just run. It's sort of like Star Trek. You know, Picard, he goes, you know, engage. He doesn't say, let's go. He says, engage. So, you know, I think exploit is exploit. It's a little bit more interesting. Yeah, and that's it. So it's these simple steps. So what did we do? So we ran an nmap scan. We ran Metasploit. We used a backdoor. We set an IP address, and we set a payload, and you've now broken into a Linux machine that had a vulnerability on it. These steps are not magic. These steps are not hard. And while I haven't tried it, I could probably get my 12-year-old son to go through and follow these steps successfully for many different hosts and break in. This is what we have to defend against. Hacking, you know, criminal breaking in, criminal remote access of devices is not hard. If you have systems that are reporting their software, their version numbers, and it's accessible to the public internet, you're going to have teenagers, you're going to have foreign nation states, you're going to have competitive organizations, you're going to have political activists on the internet, you're going to have everybody scanning, looking for these weaknesses, and running those few simple commands to break into your vulnerable servers. It's not hard. It's a lot of fun when you go through and you learn it, and then you sort of realize how easy it is to be done, and you go, whoa, hang on. If I can do that, anybody can do this. And that's it. Now that is breaking in. That's the first gaining access. When you go through to here, you can then run the commands ifconfig and whoami and ls. And when you run those commands, you're actually running them on the Linux server that you've just broken into. So that's really cool. If you then want to go one step further and establish a foothold, this is a very basic example, very basic, but it's a fun one. Because you've gained root access on that Linux server, you can add a user, set a password, add them into the sudoers file, and now, even if the vulnerability is patched, the attacker can SSH back into your system, run sudo, and keep their root access. Pretty cool, hey? So yeah, so that's an example of establishing a foothold, creating a user and allowing them to SSH back in. This is the next example. I won't walk it through step by step, but this is basically going after the Windows machine. We do the same thing of run nmap, look for vulnerabilities, run Metasploit, find an exploit for the particular software that we're trying to go after. Yes, there is a vulnerability. Yes, there is an exploit. We're going to set the remote host, set the port number, tell it that it's running SSL or TLS, and boom, you've just exploited a Windows server. Not so much exploiting Windows, but exploiting a server software that is running on Windows. And from there, you gain local service, which is not administrator, but it's not that hard to find ways to then elevate privileges within that server. That goes a bit beyond the discussion here. But yeah, that's a very simple few steps that you can repeat, the same as we did for breaking into the Linux server, for breaking into the Windows server as well. So there you go. This does not make you a penetration tester, but this allows you to understand the life cycle of an attack that attackers will go through and the life cycle that people simulating attacks, such as penetration testers, are going to do when they try and break into your network as well. This stuff is easy. Taking what you've seen and writing it into a report for somebody to read and know what they have to do to fix their network, that's the hard part. That's where you pay the big money, is for a good report coming back to tell you what are the problems and what do you need to do to fix those problems. So hopefully this has given you a good introduction into vulnerability assessments and penetration testing. Hopefully you learned something from here. Remember, this is a hands-on experience. It takes more time than we have here, but please take this information. I'm going to be putting it up into this module when we go through, but please go to the APNIC Academy, run the free virtual lab, and actually try these commands. Go through, practice what I've demonstrated and what I've walked you through here, and actually use these tools. And then the next step beyond this, get permission to do some of this, not all of this, some of this, on your own networks. Do the scanning for open ports. You know, it's a very simple thing. It's not scary, shouldn't cause problems on your network. Look for things, you know, get a vulnerability scanner. Do some scanning on a very small subnet on your network to look for vulnerabilities. If you don't have a vulnerability scanner already, there's an example of a free one that you can do. Even if you don't want to go the full OpenVAS vulnerability scanner, just run Nmap and compare yesterday's scan to today's scan and look for changes over time. Any questions on anything that I went through here? Now, I do know that it's lunchtime. I don't want to stand between you and lunch. I don't have my email address listed on here. I do have some business cards, but you can also just find me on jamie@apnic.net. Easy to find. If you want to come up, I can hand out my business card for anybody who's interested. APNIC, we are out here to support the research and education network communities. So by all means, if anybody needs assistance with any of this or beyond after this week, please feel free to reach out. Happy to assist. We are going to be running another session, or I'm going to be running another session. I think it's in this room after lunch, and that's going to be on the second most voted topic, which was the email security, I believe. Oh, it moved up to the top. Somebody voted it higher. So yeah, so the very first one is what we're going to be doing in the afternoon session. So immediately after lunch in this session, in this room, we're going to be doing email security, quick overview of phishing, SMTP header analysis, and the basics of, like I've only got an hour and a half here, basics of SFP, DMARC, and DKIM, and a little bit of TLS on SMTP servers as well. So if that interests you, I'll see you after lunch. Thank you very much, everyone. Okay, well, welcome back after lunch, everyone. This is the second session of the security tutorial workshop. So we did the voting in the first session. The voting was for email security and vulnerability assessment and penetration testing. We did the vulnerability assessment and pen testing, and in this session we're going to be going through email security. But it is interesting to see as well other people's interests, and you know, those top 6 or 7 are all very, very closely tied. So a lot of interest in security topics, which is good. So going in and doing email security, this is another one where the slides are a little bit longer than the time that we've got, so we'll see how we go through on the timing and everything. I won't spend too much time on some of the earlier slides as we go through. But we're going to be having a look at email threats, so things like phishing and others, email threats in general, and then phishing and social engineering specifically. Going to have a look at email header analysis and some of the tools to make that easier, and then finishing off with best practices for email security down at the SMTP mail server, as well as DNS level for email protection and domain protection. So for email threats, we're going to be looking at some of them. Phishing is, of course, a very common one. This is what a lot of people are being impacted as it goes after the human side of things. Phishing with the PH, of course, is a play on words with phishing as the traditional phishing and phishing pole. This is where you're luring in and reeling in real victims. The way this started is actually the naming, at least. Many years before all phishing and everything had started, there was a group of people that were exploring phone systems, and they were called phone hackers. And they used the PH of phone as something that they were adding on. So they called the hacking of phone networks phone phreaking. And freak was spelt with a PH, R-E-A-K, as a phone connection to it. So anything that was phone related had the PH. Now, a lot of internet connections starting back then was done over phone networks, so that carried through. So that's why phishing is spelt the way that it is with the PH. Also, if you know the website Have I Been Pwned, the P-W-N-E-D is including that P as well as that callback to the original phone phreaking. So phishing, using deceptive emails and messages and websites to get people to reveal sensitive and personally identifiable information about themselves. This is usually done by spoofing or forging or faking the from email address to make it look like it's coming from a trusted source. Sometimes they use real domain names to make it look like that. Later on in this module, we will talk about protection mechanisms for that. And because there are protection mechanisms, we end up with people using similar named domain names to get through and try and avoid things. Some of these similar names, you can see some examples of things down in here. Of course, we have apnic.net as the bold that we have as the example. Let me just bring up my on-screen laser pointer here. So apnic.net, that's the actual domain name for apnic, but then you can see some of the other examples. apnlc.net, so making the I into an L, but still looks a bit like apnic. Using different top-level domains, so apnic.another top-level, for example, .top. You would see apnic and think, oh, well, that must be apnic. Another tricky one that they use to get around domain blockings, and that is apnic.net.secure.email. So people will see the apnic.net up at the front and go, oh, this must be it. Of course, a lot of regular users on the internet don't know that the domain name is all the way through. They look at that first match and say, well, it's got apnic.net in it, so it must be real. Another one here is double typos, so apniic.net. Some people's brains miss over doubled words or doubled letters when they look at things quickly. You can also transpose letters, apnci, so just switching them around. Adding in hyphens where there shouldn't be one. So this is apnic.net, right? But it's got that hyphen, which makes it totally different. Another one. Dropping letters, changing letters around, and of course adding on extra letters again. So these have all come around for not just apnic, but a lot of different domain names have all had similar things like that before. We're going to look at phishing a bit more in depth in the next session, but that is one of the email threats to be concerned of. Another common threat is malware. Email is a carrier not just for messages, but also for attachments. Email was actually never built for attachments. And the way that email handles attachments at the moment is a bit of a kludge, a little bit of a hack on top of the SMTP protocol. So you can, of course, send malware, viruses that can be sent through email, opened up by the user to a whole range of activities, ransomware being a common one, but spyware is another common one, botnets and remote control, as well as loaders, where the software being run itself is not malicious, but it allows infection onto the machine to load in the actual malicious software later on. Spam, everybody understands about spam, the unsolicited commercial email. The spam emails themselves can be absolutely anything. We're differentiating spam from phishing at this point in time. So they're usually advertising some sort of commercial email along the lines here, not looking after gaining people's personal or sensitive information. We also have extortion and sextortion scams. Extortion is where you're threatening the victim or the recipient of the email with releasing very sensitive information about them. This is sometimes real and this is sometimes fake. You know, there are fake extortion scams. We've probably all received the email, at least over the past year, saying, you know, hey, I've hacked into your computer, I've been watching your camera, and I've been watching when you go to those adult websites. Of course, it's fake. They really haven't hacked into your computer, but they are doing that fake extortion, and a lot of people get afraid at that point in time and will pay money. Sometimes it is real, though. Sometimes they do have sensitive information, maybe not from your camera, but they may have your personal or sensitive information that they are holding as extortion. Another one that we had here, the fake extortion, they've actually been, over time, increasing the believability of their fake messages. One of them is that they're not just taking your email address, but they're combining your email address with information from other data breaches. And when they combine that information, they may have your email address, your first name, your last name, and your home postal address. And when you combine those things together, you can get a message like what I've put in the screenshot here. I write to you since I attached a Trojan on the website with porno which you have viewed. My Trojan captured your private data, then switched on your camera which recorded the act of your solitary sex just after the Trojan saved your contact list. I will erase the compromising video records if you transfer. From there, it actually goes on to list the home address, and I've cut it off because it's somebody else's home address, but it actually included your home address is this. They then go to Google Street View and they get a picture of your home from Google Street View and include it in the email message. I don't have a picture of that one. Again, it's somebody's personal home address, so I won't include too much. But you open up the email and you see a photo of your home from Google Street View. Now, they're not pretending that it's them personally taking a picture. You know it's Street View, but it means that they know your home address. So it starts getting a little bit more personal at that point in time, a little bit more believable. So combining data breaches with Google Street View makes for very believable emails. We also have direct email compromise. This is where the attacker gains access to your email account, either by stealing your password or guessing your username and password. Once compromised, the typical thing is using your email account to send spam messages because your email account hasn't been flagged for sending spam. So it's a nice, clean, gold standard email account that they can then use for sending a lot of spam. They can also look through your email account for all of your sent messages, all your inbox, look for any personal or sensitive information, such as password resets, maybe bank account information, credit card information, and of course, not just looking for past password resets, but activating new ones. If an attacker can compromise an email account, they have access to every other account that relies upon that email address. For maintaining access to your email account, a common one that they do is they install forwarders, or they set up POP and IMAP access. So this means that even if you change your password, they still have copies of your email being forwarded off to other email accounts. This can even maintain after you've changed your password and set up two-factor authentication. Now, taking simple email compromise to the next level is business email compromise. This is where they're targeting businesses, going after usually the high-value targets, maybe like the CEO or managing directors. They might go after financial officers as well. And by controlling their email accounts, they can actually send requests, they can approve requests, they can make changes to invoice payment details, and a whole bunch of different things like that. Business email compromise also doesn't have to attack the email account. They can just send email from other sources. So business email compromise can be two different ways. So that first one I mentioned is actually compromising business accounts. Another is sort of like sending phishing emails, but you're targeting people in businesses and getting them to make financial business transactions on your behalf. Very common one is a CEO asking their personal assistant to buy gift cards to hand out at a very important meeting. We've probably all seen those gift card spam messages. The problem is that the very first email that you receive doesn't say, I need you to buy some gift cards. The very first message you receive is, hey, are you busy right now? And it looks like it's coming from your boss or your higher level boss. And it's a very simple email message. So of course you reply back to it. And once they get the conversation going back and forth, that's where they lead on to, oh, I need you to buy something for me. I need you to buy gift cards, or I need you to make a transfer for me. Business email compromise can also start from malicious software infecting an employee's computer. So it doesn't have to be a weak password. It can start with typical malware as well. Here's a couple screenshots of business email compromise. This is a real BEC email that was received at APAN59. You can see that it's from Duncan to Blondine. If you actually look at the from address, of course, this is not an APAN59 email address, but depending upon the email client that you're using, it may only display the name by default and not the email address. In which case, yes, Duncan was the CEO of the APAN59 Foundation at that point in time, and Blondine was reporting to Duncan. So yeah, you can see here, it doesn't say, I need you to buy gift cards. It starts off with, are you at your desk? I'm in a meeting. I have a task for you to do. Now, of course, once you see several of these, yeah, this is about gift card scam. This is another one. You can see another one from Duncan, and that's because, of course, Duncan was the CEO of the APAN59 Foundation. So on LinkedIn, he is listed as the CEO. So he is a prime target. When they're doing reconnaissance as criminals, they look for people in those higher level positions. And where do you advertise your position? On LinkedIn. So here we have Duncan messaging Sylvia, and you can see this is a real screenshot. This is not me recreating it or anything. It doesn't show his email address in this client. And this is another one. Planning a surprise with gifts, need you to purchase done, email when you get this. It doesn't say what to purchase, but of course it ends up being gift cards. This is from another non-APAN59 email address. They don't try to make it look like APAN59, and that's because they need the emails to go to a real email account. They have to have that back and forth conversation. It's like setting up the three-way handshake. There has to be that back and forth. So they're not using fake email addresses. They're just using fake names. When you do hover over this one, you see that this one came from ceooffice15@aol.com. Again, I'm not making this up. This was the actual email address. AOL accounts are still being used somewhere out there in the world. There are some pretty little diagrams and posters. You know, business email compromise in all forms has gotten so bad and the impact is so great on businesses that even international policing organizations like Interpol and Europol are putting out messaging to the wider population, letting them know, hey, this is a problem, this is the things to look out for, and what it can cause damage to. If you want to see some losses due to business email compromise, there's a few examples here. Between the 11 years of 2013 to 2024, the US FBI's Internet Crime Complaint Center was recording 158,000 victims, and we're looking at about $20 billion US dollars of damage to those victims over time. A recent Verizon data breach investigation report, or the DBIR, showed the median loss at about $50,000 US in 2023. And in 2020, 95% of losses were between $250 and $1 million. So it can be quite high. The Australian Cyber Security Centre, ACSC, they've received reports of about $80 million worth of loss, about $40,000 per report. For specific case studies, we've got a few here. Twitter was compromised with a mix of social engineering, stealing credential phishing from websites. A Toyota parts supplier was hit by $37 million email scam. So that's one BEC attack against that supplier for 37 million. A Belgian bank lost 70 million euros. Ubiquity Networks, you know, they're making all the Wi-Fi gear and everything, they lost 39 million to CEO fraud. And fake invoices cost Google and Facebook over $120 million. These are not small figures. You know, like, yes, I go back here and, you know, oh yeah, some of the low end was, you know, $250 or $50,000. But it's just as easy up in the tens of millions of dollars as well. So these big CEO frauds, or BEC, definitely do happen. So that is a whole bunch of threats that we've got coming on email. A lot of it is by faking of email addresses and that. Now, looking a bit deeper into phishing and social engineering, not just as a type, but as a specific thing to look at, phishing on its own is basically sending a large number of emails to a lot of people, hoping that somebody's going to bite. If we target phishing, it ends up being what's called spear phishing. This is where messages are targeted to the individuals, maybe targeted to the organization that they're sending email to, and not just a wide email of, hey, I turned on your webcam and I've got pictures of you doing naughty things. Beyond spear phishing, there's a modification of that called whaling. Whaling is basically spear phishing targeting the higher level people in a company or higher level finance officers within a company, going after the big fish, basically. Now, besides phishing, which is email-based, we have vishing. I don't make these names up, so I'm sorry for some of the silliness of these. Vishing is basically voice phishing. This is where they use phone calls to trick people into handing over passwords or transferring money or things like that. Can also direct people to malicious websites. This is getting a lot easier with certain AI tools that can actually take voice samples and change your voice in real time to sound like somebody else. Not just like somebody else, but somebody specifically else. This is especially damaging if there is a lot of audio available, such as YouTube recordings of somebody talking, or Twitter or TikTok videos of people talking, presenting, sharing information, such as I'm doing now. Very easy to take voice samples from a larger audio sample and make very realistic audio masking. Smishing, back to a little bit more traditional. Instead of phishing by email, this is phishing by SMS. This can steer people to click on links, reply back with other information, or mostly the links to websites to get information that way. They do use a lot of URL hiding techniques because they know on a mobile phone it's very difficult to do extra checking. Also, legitimate companies will shorten URLs in SMS messages as well. You know, like in Australia, I don't think I included this example here. In Australia, we have a postal service called Australia Post. The regular email address is AusPost. Now, the real Australia Post, when they send you an SMS, it is mypo.st, mypost. And it's not a domain that they use for their regular business. It's a domain that they only use for SMS, and it has no tie. It doesn't say it's Australia Post, doesn't say it's an Australian.au domain, doesn't say it's a government domain or anything. It's mypo.st. It's horrible practice by the legitimate companies. So when you look at these, you can understand, you know, id-apple.mobi. It's like, maybe that's Apple's real mobile domain name. I don't know. Who's to say? So yeah, so there's some interesting things here on the far left. Did you request a password reset for your Gmail account? Delete this message if you did. Otherwise, send cancel and the verification code we just sent you. Now, what's that verification code? That's the two-factor code. So they have your password from a data breach, but you've got two-factor enabled, so you're secure, right? But then you receive a message like this, and it's password reset, and you go, oh, I didn't reset my password. And you're afraid that somebody's breaking into your account, and it says, well, you know, otherwise send cancel and the verification code. So you've received an SMS with the 6-digit number, and it says, oh, that's a verification code to, you know, protect your account. In reality, you're handing over your two-factor code, and now the attackers have bypassed your two-factor authentication. So yeah, very, very tricky messaging there. This one, of course, id-apple.mobi, no, that is not Apple's domain name, so they're just getting you to click on a link. Same thing for this one here. Missing packages or delayed packages worldwide is a common SMS scam. So package stopped by Australia Post, 1 December 2020, Canberra. Reason, missing address. You know, click here to confirm. The domain, they're not even trying to hide it. You know, ekp.dog. Of course, that's not a real domain name, but some people will click it. You know, it's like, oh, I was missing a package, or I've ordered something and it's been delayed. Another one here, dear NAB bank user, we've detected unusual activity. We urgently ask you to follow the following link to your account. Sense of urgency, right? And they start off ib.nab.com.au. And if people read up to that point, yes, that is the real NAB or National Australia Bank domain name. But then it has another dot, nab-professional.com. And of course, if you read the whole domain name, no, that's not the correct one. Now, I mentioned that sense of urgency that was in before, a few words of urgent and you know, something critical is happening on your system. This is a common denominator on these phishing scams. No matter where it's coming from, there is that sense of urgency. This may include threats and negative consequences, requests for immediate action. All of these things are short-circuiting your rational thinking brain and trying to get you to respond and react quickly. You also may have the messaging style. The phishing messages may not sound the same when coming from a legitimate sender. These are things that you may be able to detect, but they can also be explained. Oh, I'm typing this message on my phone, so apologies if I get some words wrong, or you know, if my grammar isn't correct. These things can be explained away a little bit. One thing to look for, though, is of course work colleagues that sound too casual, or friends that are sounding too formal. Usually that level of formality Even if the grammar is not correct, the level would be accurate. So you want to be careful about some certain wording, especially business emails that don't sound business-like. You can also find language errors. Spelling and grammar are very common signs of phishing emails. There are many theories about this. The most common theory that I agree with is that the spelling and grammar errors are there on purpose for two reasons. One, to avoid detection by filters that are looking for specific phrases. So if they change the lettering, it doesn't match the phrase. The second is that these grammar and spelling mistakes, for somebody who is smart, will be easily spotted and put to the spam folder. They don't want to scam smart people because smart people will either waste their time on purpose or they won't fall for it anyways. They want the people who aren't paying attention. They want the people that will just click through and respond to anything. So they're automatically filtering out smart people that aren't going to fall for the scam anyways. AI may help to remove these inconsistencies by making the messages better, but I don't think that's the point. If attackers, if criminals wanted realistic messages, all they had to do was take a real message and change the link and copy and paste it. These messages have been out there for years and years. Anybody with a PayPal account will receive legitimate emails from PayPal. All you have to do is copy, paste, and change the link. But they're not doing that. They're specifically putting in spelling mistakes. They're specifically putting in bad grammar, and they're crafting these by hand on purpose. So while I say AI may help attackers bypass these inconsistencies, I don't think that's the point, and I don't think AI helps make better phishing messages. Because if they wanted better messages, all they have to do is copy a real legitimate message. But that's my personal opinion. Happy to be proven wrong or have arguments on that later. Other ways to recognize phishing is unusual requests, doing out of the ordinary actions, things that, asking somebody to call on an internal phone, walking to the help desk. These are ways that you can short circuit these messages. All you have to do is train your users that if you see a weird request, stop, think, and verify with somebody else. At APAN59, we use Slack a lot. We also use Zoom, fairly common tools. If a weird request comes in by email, it is super easy to hop onto Slack, which is an authenticated platform. We don't let randos come in on Slack. We can hop on and message the person and say, hey, did you just send me that email? Why are you asking me to buy gift cards? Or you can do a Zoom call, bring up the video with them. Again, the Zoom is logged in and authenticated, and we can prove that we are talking to the right person. Mind you, the Zoom is tricky because if you're receiving a Zoom call and you don't verify who it's coming from, there are AI systems that can change your face to look like someone else's face as well in real time. So yeah, it's like the voice changing, but with the face as well. So it's easy when you're on the initiating side of a Zoom call, but if you're on the receiving side, you have to do still extra checks to make sure that it really is the person that you think that it is. Other ways to recognize phishing: inconsistent email addresses. Again, for regular users, it's teaching them what a domain name is. Where do domain names stop? How to recognize things like that. And again, getting people to slow down and look past little letter changes or little typos in email addresses that might be a bit tricky to see. Some legitimate companies may use click tracking domains for their links. This makes it harder to recognize a legitimate email. The next time you look at your email messages coming in from real companies, hover over the links. It won't be their domain name. It's these click tracking domains. If you're using Microsoft 365, it can change domain names with their safe links as well. Now, if you use the real Outlook program, it replaces safe links with the real one, but when you click on it, it goes to a safe links address. It makes it very difficult to even have a technical person understand what the real domain name is on there. And then if you do click on a link and it takes you to a website, it's not the end of the world, because just visiting a website has a very low likelihood of anything bad happening. But you then want to be looking for inconsistent login pages. If you click a link and it's taking you to a login page and it's a Microsoft login page, whereas you normally would go to like Okta or Cloudflare or some other identification system, that's an inconsistency. If you always log into one system and it's showing you a page for a different, you have to make sure that your users are understanding that only type your password into this type of website and not any others. And of course, combination attacks. Some advanced phishing combines these attacks. So you might start off with a phone call or vishing, asking you to perform actions that you received by SMS. So they're combining a voice saying, yeah, I've sent you a text message. I need you to follow that. Now you're not thinking about the text message. You're just clicking through and listening to what they're saying. That link, of course, goes off to a website that then captures your identification details from there. Now, we do have some quizzes on here. We don't have time, obviously, during this session to do all the full interactive. I will share these slides out, but these are really good quizzes for you yourselves, as well as for any of your staff and users to go through real phishing detection exercises. So both of these, I recommend both of them as you go through. It gives you maybe a dozen different messages, and you have to have a look at all different aspects of the email and guess, well, not guess, put in your assessment, your analysis. Is it a real email or is it a phishing email? It also gives you the learning about if you clicked on the wrong thing, it tells you why it is or is not a phishing email. So really good resources here. There's many others, but these are two of the better ones that I've found. This is another fun one that I use as an exercise with people when I'm doing this as a longer sit-down session, is going through the thought exercise. If you were to create a phishing email for your organization, what would it look like? What sorts of messaging would you use to get people's attention and to get them to click on a link? Some interesting ones that I've seen in businesses is saying that a company has approved bonuses for all employees, and in order to receive your money, click through this link to make sure that your bank details are correct. Everybody loves receiving money. So yeah, that's a common one. And if you tie that to particular times of year, say Christmas, it's like Christmas or end of year, yes, we've approved some bonuses for everybody. Click through here to see how to do it. Very interesting things. When COVID was going through, of course, a lot of phishing emails were based around COVID, whether lockdowns or coming down or up or down or whichever way it was going. But phishing emails are crafted around all sorts of different events. Whenever it is tax time in different countries, there will be targeted emails being sent around tax claims and tax reports and things like that. When it's Chinese New Year, you're going to see messaging around that. When you see, calendar New Year, seeing messaging around that. COVID, diseases, storms. Australia's got a storm coming through right now. My guess is that you're going to see scam messages coming through about storm preparation. And then after the storm goes through, if there was flooding and damage, you're going to see scam messages coming through in the same area for claiming insurance on those areas and maybe offering insurance for people that weren't insured. All of those definitely good lures for scams. Now, this is interesting discussions that we have here as well. Are phishing simulation tests a necessary evil, or another way to annoy people and make them hate IT? So who in the room here actually has phishing test emails that their organization sends out? Has anybody received phishing tests before? Yeah. Do you enjoy those? If you spot that it's a phishing test, do you click the link anyways just to see what happens? Like, is it valuable? Does it train users that aren't technical though? Is it something that should be done? It's really interesting. There's two very different opposing schools of thought on the usefulness of phishing simulate tests like that. So interesting stuff. I've also seen some organizations that do phishing simulations. They do phishing tests, and sometimes the people creating the tests created too realistic of an email, and too many people failed, and they got very upset, such as the bonus. You know, there's been worse, but you know, hey, it's bonus time, click here. And of course, a lot of people fell for it, and they said, oh, you shouldn't have used a bonus as a phishing lure. And it's like, but hang on, the criminals will do that. So why are we being limited in the realism of our phishing messages? So yeah, very interesting things, you know, off limits topics and things like that. And should they be off limits? Because a criminal is not going to care about your off limits. It's sort of like the vulnerability scans. You know, we were talking about in the last session, setting up a scope. And sometimes an organization or an IT manager will say, oh, don't scan these systems because they're really old and they may not behave well if you scan them. It's like, well, hang on a sec. If an attacker breaks into our network, they're going to be scanning those systems. Or if they're exposed to the internet, anybody could be scanning these systems. So, you know, does limiting the good guys from scanning the systems actually make those systems more secure or less secure? So the next little session here is email header analysis. It's mostly about the basics of how it works and pointing out some tools on how to make your life easy. When I started going through security 24 years ago, we learned to manually analyze email headers. It's not a fun process to go through. There are tools to make your life a lot easier. So just a little diagram that I've borrowed here. How email appears to work. You send it from your outbox and it goes to their inbox and it goes bang straight across. In reality, your flow of email might look like this, but it might also be condensed on one side or the other. If you're using a web-based email program or the receiver is using web-based email, then the entire side gets condensed down basically into one system. On the back end, it might be a little bit different, but you don't have an email client separately because it would all be web-based. It's accessing directly on the server. But yeah, if you look on the sending side, they've got their email client sending it to the email transfer agent, which sends it down through the server in a mail queue, through routers on the internet, hopefully going through a spam and virus filter. It's received on a mail server, and then when it's being pulled, it actually gets pulled up to an email client. Each step of this process creates logs. Each hop, each movement that the email message goes through creates fingerprints and logs, and some of those logs get added on to the email header and grows, and other logs get kept separately on the mail server themselves, and sometimes it's doubled up as that. So having a look at the email server logs, so this is the actual SMTP server that we have here, and you can see that it's this is a postfix mail server. I'm using the postfix SMTBD as an example. And you can see a lot of the information that's contained here. A lot of it is just the header information, the metadata. So it's not recording the email message themselves. It's possible an email server can save whatever it wants, but usually it's just the to, the from, and the IP addresses of other servers that it's talking to. But if you don't know the formatting, this can be quite tricky. but this records one SMTP server talking to another SMTP server. And this is great because you can't fake that. When you get down to computers, one computer talking to another computer using TCP/IP, you can't fake that. So when you get down to the logs, this is going to be your ground truth of one server talking to another server. Or if you're running a client talking to a server, again, you can't fake the TCP/IP connection at that point. We then move to the email headers. These are added on by the SMTP servers, and these email headers get added on and moved with the email message. So the headers are part of the email, but usually hidden from the client's view of things. So normal headers that you would see, subject, from, to, and date lines, and then there's a lot more email headers beyond that. This is an example of email headers. You can see down at the bottom here, this is the start. So the email headers are added on the top, going up and up and up from here, usually. And you can see down at the bottom is the stuff that was created by the sender. So the from, the to, and the date in the subject line. Going up from here, there is a lot of garbage, and it can be very difficult to go through and pull out useful bits of information. I'll highlight them here for you, but there's other bits that look like it might have been useful, like this information here. It sort of looks like some of that could have been an IP address, but it's not. You know, it's part of an email SMTP ID number. So yeah, so I've highlighted some of the greens and blues of different IP addresses and domain names that can be used. Some of these can be faked. Some of these can be inserted by the malicious or criminal sender sending things through, so that if you are trying to do this by hand, you may fall into a trap of looking at the wrong message at the wrong level and thinking that it's actually legitimate, and it may take you down a bad path for investigations. So combining this with mail server logs can be useful. But of course, doing things by hand would be very difficult. There's a few different tools to use. One of the first ones is, how do you get your email headers? If you don't know for your particular mail client, that's what this first link here is good for. This is the MX Toolbox. They do a lot of really interesting mail exchange tools. One of them is they have a list of like 100 different email clients, web-based as well as application-based, with instructions on how to access email headers for that particular version of mail client. Once you have the email headers, it's then going through and analyzing them. Now, I've included 3 different analysis tools. They're all just website tools where you copy and paste the email headers in. Make sure it doesn't have any sensitive information, but usually mail headers don't. Each one of these will analyze the information in a slightly different way. Well, not so much, let me reword that. Each one of these will analyze the mail headers and display the results in a slightly different way. Because in the end, mail headers can only be looked at in one way, but the way that they display it and help you understand what's happening is slightly differently. Additionally, I've put 3 of them in here just in case one of them disappears. You do have other header analysis tools that you can use. This first one, it actually is created by Google, so that's useful. MX Toolbox, same company that puts up all the instructions on how to access them. And IP2 location has a free email tracer as well. This doesn't do anything magic. It takes all the lines from the email header, pulls out the right ordering of them, which ones would be fake and dropping those off, pulling out the domain names, pulling out email addresses, what can be trusted, and what could just be extra information thrown in for fun. So yeah, an easy exercise is practice this on your own email messages. Find an email that's not very sensitive, learn how to access your own email headers, go back to one of these 3 free tools, or even all 3 of them, and try doing your email analysis on each one. Which one is going to give you the output that you can understand easiest, and follow through to find out what mail server did it come from. Remembering, of course, that some investigations of this may have to involve you identifying a mail server and then contacting the owner of that mail server for the actual mail server logs for more information from there. But yeah, useful and interesting tools. So that's going through extracting and analyzing SMTP email header information. And the last bit that we've got here is best practices for email security. This is where we're actually looking down at the SMTP server level of things and how can we make sure that our mail servers themselves are having all of the layers of protection added onto it. One of the first ones here is making sure that your mail servers are set up to handle encryption properly. And this is encryption from one mail server to another. Not so much the client side, although important, but they're usually done almost by default now. But you'd be surprised at how many mail servers do not have encryption or do not have good encryption when sending messages from one server to another server. Without encryption along the way, of course, we're exposing our messages not only for confidentiality reasons that people can read email as it goes across the internet, but also for integrity. If somebody can see an email message going across the internet, if they're in the middle, they can change the email as it goes through as well. So email communication for a lot of SMTP servers, communication starts off unencrypted. The very first connection is completely unencrypted, and then it issues a start TLS command where it then upgrades the connection to encryption. There are so many mail servers that not only don't supply encryption or don't have good encryption, but a lot of them will fall back to unencrypted. So again, if somebody is in the middle of this communication string, all they have to do is interject something that says, don't upgrade to encryption, and it will just carry on with an unencrypted email communication. That hijacking, that man-in-the-middle connection can be done easier than you think. They don't have to physically be on the wire in between two mail servers. If you do DNS cache poisoning, you can actually redirect an email server to send messages to a totally different server thinking it's part of that domain name. And a little bit trickier, but has been done multiple times, BGP hijacking. If you don't have RPKI to protect your BGP routing, you can actually hijack an entire IP prefix and have that pointed somewhere else. So you would actually own somebody else's IP addresses and run a server on that side, receiving all of the mail that would normally go to them. So, SMTP encryption, how can we support it and make sure that it gets done? So DANE stands for DNS-based authentication of named entities. DANE associates a TLS certificate with a server and puts that into a DNS record. This allows a sending server to then query DNS for your server, see that there's a TLS certificate, and require TLS to be done. Because if something like this exists, it's you advertising to the world, yes, I'm running TLS, yes, this is the certificate I should be running, and yes, I want you to use encryption. Do not fall back to unencrypted. So this is one of those ways to go through and do it. This does require DNSSEC to work properly because we're relying upon DNS. Now, DNS itself is unencrypted, so you can't go from one unencrypted form to relying upon another unencrypted form because it's unencrypted and it can have all of the same problems. So it relies upon DNSSEC. DNSSEC provides the signing for all DNS messages to authenticate that it hasn't been modified in the way. So it's not encrypting, but it is providing digital signatures for it. So the existence of a TLSA record signals that start TLS should be used and must be used for it. So DANE is a great way of advertising to the world, yes, we want encrypted email, we support it, we have a certificate for it, definitely use TLS for email. Different you could say that this is competing in some ways, but it's a different way of providing that encryption assurance for SMTP servers is MTA-STS. You may have heard of HSTS for HTTP. This is HSTS, but for mail transfer agents, which is why it's called MTA-STS. So in the same way that HSTS provides that certificate assurance that yes, this should be done for an enforced SMTP or enforced HTTPS connection, this one does the same thing. This declares the ability to use TLS and that TLS is required or enforced. This one is done a little bit differently though. It's different today in that in addition to a DNS record, you actually have to publish a policy on a website. So this is a weird thing that not only for your email server to work that you have to have DNS, of course, but you have to have a web server publishing a policy for your domain for your email server. So it starts getting a little bit more complicated, but of course everybody has a website for their companies, so it's not too difficult here. This does require TLS version 1.2 on your mail server, which is not a large hurdle to reach. If your mail server doesn't support TLS 1.2, you're probably running software that's 10 years old, and you should be upgrading your software anyways. One of the other requirements here is that the certificates must be signed by a trusted root CA. So on the previous one, it relied upon DNS and DNSSEC. For this one, it's relying upon the PKI structure of the certificate authorities. So you have to have a properly signed root CA. You should use DNSSEC, of course, because it does use DNS, but it's not mandatory for this case, because it's relying more upon the web server side of the policy. So, very simple recommendations when it comes to encryption for SMTP servers. Get a valid TLS certificate on your SMTP server. It may sound obvious, but SMTP servers, like 50% of them, don't have valid TLS certificates on them. They might be expired, they may not exist at all, they might be self-signed, they may not even be trusted in any way. So get a valid, current, non-expired TLS certificate. Make sure that your SMTP server is configured to support TLS 1.2 and 1.3. Disable weaker TLS versions. Test your TLS configuration. There's tools like testssl.sh. That's not a website, that's actually a tool. It's a bash script, why it's .sh. Set up DANE if you already have DNSSEC on your domain. If you don't have DNSSEC, then use MTA-STS instead. But it will require that your TLS certificate that we mentioned on the first point is actually from a trusted root CA and not self-signed. And then set up DNSSEC anyways, because DNSSEC is good for all of your domain. Now that's about the encryption side of things. Beyond encryption, we then have the authenticating email senders bit to prevent spoofing or faking and forging of sender email addresses. This is where DKIM comes in, domain keys for identified mail. DKIM is a method for detecting forged and spoofed addresses. When an email is sent, it's signed by a private key of that server and then validated on the other side using the public key that is published via a DNS record. Of course, because it's relying on DNS, you should use DNSSEC, but it's not mandatory. Another way is, of course, using SPF. SPF is the most common one. As much as DKIM is great, the actual penetration into the regular market may be around 15–20% of domains are actually using DKIM. SPF is like 80% or higher. A lot of people are using SPF. That's a little bit easier to implement. So SPF is a more simple validation system to prevent spoofing. It works by verifying that the incoming mail is coming from a server that has been authorized. So is the mail coming from where it should be coming from? This is done through publishing an SPF record as a text record in DNS and can prevent mail spoofing and phishing attacks. One of the downsides for this is if the email is coming from a shared mail server, then the attacker could use the shared mail server to spoof messages coming from it. So an idea of shared mail servers is, of course, Google. Microsoft and all the others have the same problem, but Google has a defined set of outbound email servers, right? And almost all Google customers are using those outbound mail servers. So if you have SPF records saying, oh, only my domain can come from here, and now I can't be spoofed, well, all it means is an attacker, a criminal, needs a Google account, and now they can send email as you and satisfy SPF records. So SPF is like a low bar, but it's easy to step over, isn't it? So it blocks some things, but it's not perfect. DKIM actually will be a lot better. And you can implement SPF and DKIM at the same time. Now, you've got SPF, you've got DKIM. How can we make sure that we actually have reporting on these things? Well, this is where DMARC comes in. DMARC is like a layer over top of SPF and DKIM. DMARC is an email validation system to detect and prevent email spoofing. It extends SPF and DKIM to specify how to check the from address, how to handle failures, and how to report from the receiving side if something is weird. If you're seeing spoofed messages or faked messages, to actually report back to the true origin where it's coming from. Yeah, so this helps prevent email spoofing and phishing attacks, but none of SPF, DKIM, or DMARC, none of that helps with the server-to-server communication. That's the TLS communication we talked about before. So SPF, DMARC, DKIM, that's great, but it's only one piece of the overall puzzle. Don't forget about basic encryption. When it comes to encryption, we are so used to our web browsers being so good in encryption. You get that lock symbol, you can get a warning message if it's unencrypted, you get a warning message if a certificate is out of date. You don't get any warning messages if TLS encryption fails on SMTP, because so many SMTP servers fall back to unencrypted. How would you like if your web browser fell back to unencrypted if something went wrong without notifying you? You know, you'd be furious. You know, the web browsers are so good at letting you know when something goes wrong. You just don't get that with email. Some of the other problems, though, of course, we have to make sure that our mail servers are protected against is making sure that they are not open relays. Believe it or not, when the internet first started and mail servers existed, all mail servers were open relays on purpose so that anybody on the internet could use any mail server to send email to anybody else on the internet. The internet in its foundation, in its formation, was actually very trusting. It was very open and everybody could use everything to their advantage. Of course, that led to spam being sent out and spoofing of email addresses. So first thing, make sure that your SMTP server requires the auth authentication for any email submissions from your clients. Don't just trust that anybody who can talk to your mail server can send messages out through it. Try not to allow unauthenticated email submissions even from internal or trusted IP addresses. Try to make sure that everybody is authenticating to your server. This is a little bit of that zero trust. It's a very tiny bit of zero trust, but you should never just trust an IP address to do whatever it wants. You should always have some form of authentication in there as well. You should use separate ports for submission and relay. This is so submission can be verified with authentication and relay is being sent out from server to server. Reject invalid recipients during the initial SMTP connection to reduce sending non-delivery reports later. Non-delivery reports are bounce messages, and bounce messages are actually used as many different attacks. Denial of service is one of them, to annoy people getting floods of these bounce messages into their folder. But it also can be used for sending the message, like actually the content being bounced and people listening to that as a spam, as sort of a phishing email. Yeah, and also if you are sending too many bounces to third parties, your mail server may get flagged for spamming because they were unintended emails. So yeah, you want to be careful with that as well. And only allow your mail server to contact out on port 25. You want to make sure that clients can't talk out on port 25. You want to really restrict that because, again, if you have unknown clients or mail servers talking out on port 25, you can get your IP address range blacklisted and blocking mail from your legitimate mail server as well. Forward confirmed reverse DNS. It's a very long name for what is sometimes just called full circle DNS. This is where your mail server is set up not just with a forward DNS that mail.domain.com goes to your IP, but having a reverse DNS record as well. Also making sure that your mail server itself is configured for the name that you're using in DNS. And the reason for this is because anybody can create forward DNS. All you need is control of DNS for that domain. But to create a reverse DNS, you have to control the IP addresses. Only the I try not to use owner because technically you don't own IP addresses, but only the owner of an IP address block can create the reverse DNS record. And that proves that the owner of the network addresses is confirming, yes, this is the mail server, and yes, this is the mail domain that we're using. If you don't have that full circle DNS that is forward and backwards in the same way, it is quite possible that your mail server will be added to a spam block list and that you will lose email messages along the way. This is a very, very common one that even at APAN59, when people say, oh, my IP address is on a spam block list, you know, I need you to give me new IP addresses that are clean. It's like, well, hang on. Can't we just fix why are you on a spam block list? And when we investigate, it's usually because they've set up a new mail server, they haven't put in the reverse DNS with the same name, or they haven't put in one at all, and spam block lists look at this and go, you're just some random person running a mail server. This is not an authorized mail server. So yeah, when you do it, you want to make sure that your hello or LO message is following the RFC naming, that it is following your forward DNS naming, and that your reverse naming is the same as well. You also want to make sure that you're using A records and not C names. C names is another one that some spam block lists don't trust, and they might put you on a block list. Another one to look at for mail servers, disable POP and IMAP. This is where you want to limit damage. If you're not using POP and IMAP, disable it. It is a very common way for attackers to have a backdoor access into mail accounts. So if you're using Microsoft 365 or Exchange servers or anything like that, where everybody should be using Outlook and approved communication, disable all the POP and IMAP. A lot of criminals, when they break into accounts, will set up a backdoor access in POP and IMAP, which gives them extended access to email going into the future. Also blocking forwarding. This is another one. When someone breaks into an email account, one of the first things they do is they set up email forwarding. So even if they get kicked off the server, password changed, if the email forwarding is enabled, then it allows messaging to be pushed out. Additionally, even if we're not talking about criminal attackers coming in and doing this, if you have staff and employees within your organization that are setting up forwarding of email to their personal email addresses, you now have internal, possibly sensitive confidential messages being sent to a third-party personal email account that you don't have control over. That's usually against acceptable use policies for most organizations. And if it's not, you might want to review your acceptable use policy statements. This is, of course, something that is useful not just for workplace emails, but for your own personal email accounts. If you have a Gmail account, go in, disable pop and IMAP, assuming that you don't need it, disable pop and IMAP, and check your email forwarders to make sure that you don't have any malicious email forwarders going on as well. And of course, other simple best practices, make sure that you're updating your software regularly. As I mentioned, if your email server doesn't support TLS version 1.2, you're running really old software. You probably have other vulnerabilities in there. Remember when we were doing the penetration testing, we were scanning for open ports, we're looking at banner messages. People know what version of software you are running. And if there is a vulnerability now or tomorrow, they will find it quickly. So even if today you were running the most up-to-date software, Shodan and Census will have a copy of what version you're running. And as soon as a vulnerability is released for that version, criminals will be going to Shodan, they will be going to Census, looking for that version and attacking you quickly. These databases are pre-populated with every version of every software on every IP address. So we have to be very vigilant about upgrading our software quickly to make sure that we are not easy targets. Similarly, logging and monitoring. Remember about the email header analysis, that the mail server logs are useful. We want to make sure that we are keeping those mail server logs. Make sure that they're turned on, that you have the right level of verbosity, and that you are keeping those to be able to detect suspicious activity. You also want to have logging and monitoring for any forwarding rules being created. This is really easy to do for Microsoft 365 because you shouldn't have users forwarding mail to their personal addresses. So when you see these new forwarding rules, it may be an indication of illegal activity. It could also just be the user doing something against policy, but either way, you want to be notified early. And of course, employee training and awareness. As we looked at a lot of those phishing emails, a lot of regular users don't know domain names very well. Doing training and awareness is going to help. Even if you don't do phishing simulation tests, if you train people how to spot domain names that look a bit funny, it's going to help them out in the long run. Additionally, probably the biggest thing for training and awareness is that if people ever think there's something weird or wrong, teaching them to stop, think, and ask for a second opinion. Make sure that your IT help desk is open and accessible, and make sure that they're there and happy to help people to check and give a second opinion on email. Because the moment staff members feel that they are too much of a bother or the help desk is too busy, they're just going to click on the links and they're not going to bother about checking with the help desk if an email looks suspicious or not. Other best practices, don't allow applications to be abused to send spam. This is a common one for web forms, where you've got maybe a feedback form or something like that where people can fill in information. You want to make sure that the to and from addresses are hard-coded. If something is just included in hidden HTML, attackers can go in, modify that hidden HTML, and then send out spam messages via your form and your mail server. Now your email server is going to get blacklisted on a spam block list, and you're not going to get any of your emails sent through. So any of these web forms, the to and from address has to be absolutely hard-coded on the server side. Don't just hard-code it in hidden HTML, not good enough. You also might want to think about putting in some sort of a CAPTCHA to slow down automated messages being sent through. If you don't have a CAPTCHA, again, criminals can go in and flood your email system or whatever the to address is going to be, flood that mailbox. You also want to validate email addresses before subscribing to a mailing list. I have a Gmail account, like literally at gmail.com, that I have never used for anything legitimate at all. Okay, I've got a personal email address, personal domain name, and I use that. But long ago when Gmail was invite only, I got an invite and I got my name at gmail.com. Now, my name isn't very common, but there's at least 5 more of me in the world. And I know that because I keep getting signed up for mailing lists. And I keep getting all of these. They're not spam. They're actual legitimate mailing lists that I'm receiving messages for. I even got signed up for Facebook at some time on this Gmail account. It's not my Facebook account. But at the time, Facebook did not verify that I actually signed up. And I definitely didn't click on a verify email when it came through. So a lot of these systems didn't verify that I requested to be added onto the mailing list, and now I'm on all these mailing lists. I'm on Instagram, apparently. I'm on Facebook, but it's really it's like a teenage girl in the United Kingdom that has the same name as me, because Jamie is both a masculine and feminine name. So yeah, I don't know how it got through, but these companies didn't verify with me. They just, oh, someone typed in my email address and boom, I got signed up for all these mailing lists. Yeah, horrible. Don't do that, because that's a fast way to get blacklisted and on spam block lists as well. Also make sure that you include unsubscribe links in mass mails, even if you've got double opt-out, even if you've got people confirming that they want to be added on. If you don't have unsubscribe links, people will go into Gmail and report you as spam. Boom, now everybody using Gmail will get your email sent into spam. Not something good as well. And that's a difficult one to get out of. You don't ever want Microsoft or Yahoo or Google to add you to their spam list. Investigating spam block lists. So just imagine that you have ended up on a spam block list. SMTP servers can get on these block lists. And when it happens, it's your IP address. Sometimes the entire net block is blacklisted. So if you're using a mail server and on the same net block are other mail servers, if they get blacklisted, yours might get blacklisted as well. And that's a tricky thing to get off as well. So, you know, if other organizations are using the same block list as them, your mail is going to maybe get 10% of recipients not receiving it, maybe 20% of recipients. The investigation is really difficult because it looks like everything's working well. It's working for these people over here. Why is it not working for you? Because they're using a blacklist. Common reasons for being on a blacklist, obviously sending spam. If you send spam, you'll get added to a spam block list. But if any of your customers are sending spam, any of your users are sending spam through your mail server, you could get on the block list. If you're on a similar IP address block, you could get added onto a spam block list. If you send email to a spam trap, you could get added to a block list. Spam traps are special email addresses. They look normal, but they're special email addresses that are created and put out there on the internet that should never receive email because they've never signed up for anything, they've never advertised it. And of course, some people will try a whole bunch of different email addresses, and if they get to one of those, they know that it's a dead email address that has never requested anything, so if anything is sent to it, obviously it is spam. If you allow email spoofing, usually combined with sending spam, but if you allow spoofing of email that shouldn't be coming from you, you can get added onto a spam block list. And of course, all the things that I mentioned before, if you don't configure your mail server or your DNS correctly for the full circle DNS, you can get added onto a spam block list. So to investigate these, some of the things that you can do is you can go, if you have a suspicion of a specific spam block list that you might be on, you can go to that spam block list website and you can do some querying on their site to see if you're on and maybe some details about why that you're on or how long that you've been on. An example, uceprotect.net, a very common spam block list. They've got a real-time block list that you can go through and check, so the rblcheck.php website. There's also some aggregator sites. These sites do checking against many different spam block lists and will report which ones are blocking you. But you still then have to go to that block list in order to see why and maybe request a recheck. MX Toolbox, we talked about them before. They've got a great super tool that can do many things. One of them is checking against block lists. DNS-BL, so DNSblocklist.info, as well as valley.org. These are other ones. At the time of writing this, they were working, so hopefully they all work still. Go to these different sites, put in your IP address of your mail server, and check against a whole bunch of different block lists from there. If you are listed, you need to go to the details section and figure out why that you're listed. It might be as simple as you don't have reverse DNS, but it could also be that neighboring IP addresses were sending spam, which is a difficult one to deal with. And we don't have the time to go through and do it, but as an exercise for yourselves, there's a few different IP addresses. You can also try your own SMTP mail server IP addresses, and you can go through and do some querying and checking up for them. What you can do if you want to check your own mail server, if you don't off the top of your head know your SMTP server IP addresses, all you have to do is an NS lookup or a dig, look for your mail exchangers for domain, and then take your mail exchangers and convert them from forward DNS to the IP addresses. Yeah, so that is that. Any questions on email security? There's a lot of content in that one. I'm very lucky I got through with like 4 minutes remaining before afternoon break. But I do have a bit of time if anybody has any questions on anything that I've covered in that presentation at all. No, it's a lot of information. As I said before, I do have some business cards up here. I am here for the entire week as well. I'm easy to contact. I'm even on LinkedIn if you want to try and find me on there. But I'm happy to provide any assistance or support on anything talked about here into the future. Additionally, because we just voted on these two topics, I will get PDFs of these slides put up onto the schedule, the APAN59.sketch.com, so you will be able to download these PDFs. I'd say later tonight, but probably worst case scenario is tomorrow at morning tea. Because I have to create them, send them to the secretariat, and get added on. But by tomorrow at morning tea, these slides should be available. Additionally, you can email me for copies of these slides. Any of the training material and slides that APNIC creates are under Creative Commons. So while I will be publishing the PDF files, if anybody would like the original PowerPoint PPTX, please email me. Happy to share them with you. And even when it comes down to all of the other topics that we went through, where's the other topics that we went through? Oh, there it is. If it's any of these that you may want to use within your own organizations, please contact me. I'm happy to share the information. Some of these have been recorded as webinars in the past, old versions, so there might be some audio recordings out there of me, but I can also share the slides with you as well. Yes?
On some, so prior to this, there was one discussion on conducting of phishing emails. So if I may share some of the experiences that I had, and we could have a discussion on this. So over in my organization, actually from my office, we conduct the phishing exercises. Fortunate or unfortunate, the responses from our staff, which determines the number of fall prey rates, is a benchmark at our board level. Okay, so what happens is that for two of the more recent phishing exercises, we actually did very tricky phishing exercises, right? Just like what Jamie shared, we did things like leveraging on the Lunar New Year. We published, say, there's a discount. Please, if you haven't bought your stuff, click on the link and you get a huge discount. And as usual, people will click on it, right? The other thing we did was like what Jimmy mentioned, promotions and titles, new titles. And these are very captivating things, right? You want to know who your colleagues have been promoted, what designations are they having. And so yes, the fall prey rate was very high. What resulted was that it surpassed the benchmark, and it had to be reported to the board for my organization. Okay, so what happened next was that then my CE came to me and said, "Hey, John, what did you just do? No, you just made the whole organization look bad, right?" But the real thing was that we like what I say, are the hackers going to say that no, you're not? They're going to set the easy questions. So these were difficult questions, and as a result, yes, the people fall prey to it. So we had a huge discussion about it. Should we be setting difficult questions or should we be setting easy questions, right? To prove the case, we set one easy question. Yeah, everybody passed, right? Fall prey rate was really low. So it proved the point that, yeah, you can set very easy questions and that everybody, if you set a question like, change in procurement process, nobody's going to click. There are some the procurement people, right? So the thing is that we recognized, right, that we should be setting difficult questions. Maybe not all the time, but the other part of it was that, the other thing we talked about was the awareness. So we did a lot more conscientious awareness. Those who fall prey once, we put them through another quiz. Those who fall prey twice, set them for workshops. Fall prey 3 times, we get a face-to-face. So we try our best because, again, at the end of the day, we individuals to pass. What happens if you do, so my deputy CEs, how they fall prey 4 times or 5 times? Say, what suggestions are there, right? So we decided if you do it 4 times, 5 times, we refer back to HR to take the decision. But what I'm just saying is that, I think we can approach the problem together holistically and say, really, yes, we want everybody to improve, but it's not about the questions. It's not about the phishing questions that we're putting up. Yeah, so just wanted to share, if you do such tests and you face the issue, and we can discuss through the various options that we can take together. Yeah, thanks.
Yeah, thanks very much for that. One thing that I've seen in some phishing programs in specialized software and as a service, as well as books on training how to run phishing simulations, is sort of like a ramping up. Starting off with the easy ones. Don't just hit people with a really hard phishing test because you're going to annoy a lot of people. Ramping up as you go through and then alternating between mediums and highs. But the other thing that you have to remember is you may have new staff and new employees joining it all the time. So if you're ramping up and then someone new joins, are you then customizing that they start from the easy ones as well? And that's what some of the really fancy software can do, that is recognizing new staff, new employees, and introducing them into more education before the testing and on the way up. And it's something that you have to think about, especially for large organizations. A lot of movements of staff back and forth. And yeah, it is a difficult case. And it's even more difficult, yes, what do you do when someone fails 5 times? Take their email access away? Yeah, probably not. But yeah, it's a lot of challenges. So definitely, if you're going to implement something, please read of other people's stories and prepare yourself for different cases that may come up for different staff members. But yes, thank you very much for sharing. Any other questions that anyone would like to share? Excellent. It is 3:03. I won't hold you up for afternoon tea. Thank you very much for joining me for these sessions. Please do come and grab my business card or come talk to me later as you see me around for the week. Thank you very much, everyone.